Today, we are going to deep dive into a topic that is truly revolutionizing how we think about artificial intelligence, AI agents, and multi-agentic systems. So, let's start with the basics. What exactly is an AI agent? At its core, an AI agent is an LLM-based system that has a specific goal, understands information gathered by its senses, like data from sensors, user input, or information from the internet. It thinks and makes decisions based on its perception and internal goals. It processes information using a brain, often a large language model or LLM. It can plan actions and even decompose complex tasks into smaller subtasks. And it can act autonomously, meaning it can take actions to achieve its goals. These actions could involve using tools, sending messages, or controlling physical systems. Well, we already have agents around us. For example, your thermostat. You set a goal, the target room temperature, and then engine decides if it needs to adjust the heating or cooling, and then acts by turning on the HVAC system on or off. But it is a very deterministic scenario, right? There are only three possible outcomes: either turn on heat, or turn on cold, or do nothing. What about tasks that require you to apply logic and reasoning? That is AI agents can help. Imagine a personal AI stylist. Your local barbershop has introduced an AI-based personal stylist. This stylist monitors the growth of your hair through Google Home or Alexa and decides what makes you look your best and when you need to look best based on who you're going to meet that week. And then it books a haircut appointment and sends you an Uber if your car is out of auto service. I know, probably no one wants such a stylist. Hey, let's get creative here, all right? But that would be an agentic AI system. Multiple agents come together to create an AI experience. Wait, did I just say multiple agents? Why can't one chatbot with integrations to tools using model context protocol servers do it all? Here's why: loss of context. Among many reasons to have multiple agents instead of just one is the need to preserve all the context. I know we have up to 2 million tokens in our context window nowadays, but research shows that LLMs lose their focus when there is a large context. We want these agents to do one task and do it correctly. Imagine what we are asking: our hair. So it's important to separate the tasks and make sure you get the best haircut you need. Second reason is generalists versus specialists. Specialists will do one job and they will do it right. Imagine one agent is an observer that is integrated with your Google Home camera. The second is a record keeper. It keeps a record of what makes you look good. The third agent is your calendar assistant, who looks at your calendar for who you are meeting that week and when. The fourth agent books the haircut appointment. And the fifth agent sends you the Uber. This allows for way better decentralized decision making. The other benefit is you could use the same agent to do a different task. For example, the same calendar assistant agent that helped you book your haircut can also manage your work calendar in a different agentic ecosystem. This is why it is important to break down the agents based on their goals and manage them individually. Technically speaking, it is like microservices architecture, which improves scalability, resiliency, efficiency, and so on. Well, this sounds like a complex system to design. How do I design an agent like that? I know what you're thinking. Architecting a multi-agent system is a bit like being a manager. You need to understand what work needs to be done by your team, how you want to organize your team, hire the right people, clearly identify and assign responsibilities, create an environment and ecosystem for your team members to interact with each other and the data they need, and finally, create a performance management system so you can measure and improve your team's performance. Let us see how each of these steps map into designing a multi-agent system. You will be setting the overarching goal for your multi-agent system. Secondly, You will have an agent orchestration approach, which is where you decide whether you want a centralized team where a single manager delegates all the work to all your agents, or a decentralized team that manages its own plans and execution. Or do you want a hybrid approach where a manager handles some level of high level planning? Or maybe you want a system where each agent decides which other agent it can tap into dynamically, perhaps using something like an agent to agent protocol. Once you have the orchestration approach, you can decide what agents you need and define their goals and backgrounds. As you do this, you will identify the tools that each agent will interact with and create those interaction points, which could be using MCP servers. Finally, you will create a feedback mechanism so that the agents can learn from their prior work through feedback and adapt new strategies. At this point, I hope you have a good understanding of how you should think about designing a multi-agent system. I have done a hands-on video on implementing a multi-agent system using Crew AI and Gemini. If you are interested in a more technical and hands-on video, please take a look at that. I will post the link in the description. You may ask, it sounds great, but what tools are available today so I can learn them and be resourceful in this agentic AI era? Great question. The good news is you don't have to build everything from scratch. There is a tool for every skill level. If you are super hands-on and can code, I strongly recommend tools like Crew AI, Google's Agent Development Kit, or LangChain. If you're more of a visual person but still like to build ground up, then LangGraph is a great place to start. If you're looking for powerful pre-built integrations with less technical background, try out Google's Agent Space, Microsoft's Audigen, or Anthropic's Claude. Get your hands dirty and you will not regret it. I highly recommend you take this free course on creating multi-agent systems with Crew AI on deeplearning.ai. I will put that link in the description as well. Make sure to take a look at it. AI agents and multi-agent systems are not just theoretical concepts anymore. They are becoming a reality, transforming industries from customer service to scientific research. What do you think about the future of multi-agent systems? Are you excited about their potential, or do you have concerns? Let me know in the comments below. If you found this video insightful, please give it a thumbs up. Subscribe to Mind Your AI for more deep dives into the world of artificial intelligence. And hit that notification bell so you don't miss our next episode. Thanks for watching, and I will see you soon in the next one.